In one of the driest regions on Earth, where rainfall is rare, rivers are scarce, and groundwater is disappearing faster than it can be replaced, Jordan faces a crisis that threatens its very survival. This is a country where water scarcity is not a future concern, but a daily reality, one that affects homes, agriculture, industry, and national stability. For decades, Jordan has ranked among the most water-poor nations in the world. Population growth, climate change, and regional instability have pushed its limited water resources to the edge. Wells have been drilled deeper each year. Aquifers have dropped to dangerous levels. Entire cities depend on strict water rationing to survive. Yet along Jordan's southern edge lies a vast, untapped source of water, the Red Sea. The challenge was never the presence of water, it was how to move it. This is the story of the Aqaba Ammon Desalination and Conveyance Project, one of the most ambitious water engineering projects ever attempted in the Middle East. A plan to turn seawater into life and push it uphill across a nation of mountains and desert. Jordan's water reality. Jordan receives very little rainfall. Most of the country is desert or semi-arid land, with precipitation that is unpredictable and unevenly distributed. Traditional water sources such as rivers and seasonal streams provide only a fraction of national demand. Groundwater once served as a buffer, but decades of over-extraction have left many aquifers critically depleted. Some are now classified as non-renewable, meaning they will not naturally recharge within human timescales. As the population grew and demand increased, Jordan reached a hard limit. Without a new source of water, shortages would worsen every year. The vision bringing the sea to the capital. Jordan's capital, Amman, sits more than 300 kilometers from the Red Sea and at an elevation exceeding 1,000 meters above sea level. Any solution involving seawater would require not only desalination, but one of the most challenging conveyance systems ever built. Engineers proposed a bold solution. Desalinate seawater in Aqaba, Jordan's only coastal city, then pump that water northward across deserts, plateaus, and mountain ranges, delivering it directly to the country's most populated regions. This would not be a canal, it would not rely on gravity. It would be a pressurized pipeline system, lifting water higher than most skyscrapers stacked end to end. Desalinating the Red Sea. At the heart of the project lies a massive desalination plant in Aqaba, designed to process hundreds of millions of cubic meters of seawater each year. Using advanced reverse osmosis technology, seawater is forced through semi-permeable membranes under high pressure. Salt, minerals, and impurities are removed, leaving fresh drinking water behind. The plant is designed with energy efficiency in mind. High-pressure pumps are paired with energy recovery systems that capture and reuse pressure from the brine stream, reducing overall power consumption. This is not a simple filtering process. It is industrial-scale chemistry, operating continuously in a harsh coastal environment. The pipeline, pushing water uphill. Once desalinated, the real challenge begins. Fresh water must travel hundreds of kilometers inland, climbing steep elevation gradients toward Amman and surrounding cities. Unlike canals, pipelines do not benefit from gravity in this case. They must overcome it. Engineers designed a multi-stage pumping system with powerful pump stations positioned along the route. Each station boosts pressure just enough to push water to the next segment, preventing pipe fatigue and energy loss. The pipelines themselves are massive steel structures, engineered to withstand extreme internal pressure, temperature changes, and seismic activity. Every joint, every weld, and every valve is a potential failure point and must be engineered accordingly. Building across desert and mountains. The pipeline route crosses some of Jordan's most challenging terrain. In the south, the desert is unforgiving, temperatures soar, sandstorms threaten construction, and access is limited. In the north, the terrain rises sharply into rocky plateaus and mountains, requiring deep trenching, blasting, and stabilization. Construction crews operate under extreme conditions, often far from cities or infrastructure. Temporary roads, camps, and power supplies must be built just to support the work. Surveyors use satellite positioning and laser alignment to maintain precise gradients and avoid geological hazards. Even small alignment errors can lead to pressure imbalances that shorten the system's lifespan. Energy. the invisible cost. Moving water uphill on this scale requires enormous energy. Pumping stations consume vast amounts of electricity, making energy efficiency critical to long-term viability. Jordan's strategy includes integrating renewable energy sources, particularly solar power, to offset operational costs. In desert regions with intense sunlight, solar farms are positioned to feed electricity directly into pumping stations, reducing reliance on imported fuels. The water system and the energy system are inseparable. Without power, the pipeline stops. Without the pipeline, cities run dry. Storage and distribution. Once water reaches central Jordan, it enters a network of storage reservoirs and distribution systems. These reservoirs provide buffer capacity, allowing supply to remain stable even if desalination or pumping is temporarily reduced. From there, water flows into municipal networks serving homes, hospitals, schools, and industries. For millions of people, this water is not supplemental. It is essential. Why this project is different? Unlike many water projects, the Aqaba Aman system is not designed to support agriculture at scale. Its primary purpose is human survival, ensuring drinking water security in one of the most water-stressed nations on Earth. This focus changes every design decision. Water quality standards are higher. Reliability is prioritized over expansion. Redundancy is built into every critical component. Failure is not an option. Environmental and regional considerations. Desalination produces brine, concentrated salt water that must be discharged carefully to avoid harming marine ecosystems. Engineers designed outfall systems to disperse brine safely into the Red Sea, minimizing environmental impact. The project also considers regional geopolitics. Water security in Jordan affects stability across borders. Ensuring reliable supply reduces dependence on shared rivers and strained groundwater reserves. This is engineering with geopolitical consequences. A project decades in the making. The Aqaba Aman project did not emerge overnight. It is the result of decades of studies, feasibility assessments, and negotiations with international partners. Financing such a project requires global cooperation, public-private partnerships, and long-term commitment. Construction timelines stretch across years, not months. But for Jordan, delay carries its own cost. Every year without new water pushes the country closer to crisis. When the system comes online, when fully operational, the Aqaba Aman desalination and conveyance system will supply a significant portion of Jordan's national water demand. Cities will gain stability. Water rationing can be eased. Aquifers will have a chance to recover. For the first time in generations, Jordan will not be entirely dependent on rainfall and dwindling groundwater. Engineering is survival. This project is not about innovation for prestige. It is about survival through engineering. In a land where nature provides almost no margin for error, Jordan chose to build its own lifeline, from the sea, across deserts, up mountains, and into homes. So now you've learned how Jordan is attempting to solve one of the most severe water crises on Earth by turning seawater into life and pushing it uphill across an entire nation. Do you think desalination and long-distance conveyance are the future for water-scarce countries? Let me know your thoughts. And join me for the final story in this series of humanity's most ambitious mega projects.